We present the design of the sustAGE system architecture, describing the individual modules, their role and interactions among the different components. We conceptually divide the system in 5 core layers, namely the monitoring, streaming, personalization, recommendation, and interaction layers. Various IoT devices collect data in real time. Cameras monitor people and objects in key working areas. Smartphones collect speech samples. Beacons provide indoor positioning, while GNSS receivers are used for outdoor positioning. Garmin smartwatch devices gather heart rate and accelerometer data. Finally, environmental sensors measure temperature, humidity, wind speed, and noise levels in the workplace. The monitoring layer comprises components that receive raw sensor data and perform initial processing before forwarding them to the next processing layer. User actions monitoring is responsible for detecting typical user behavior patterns, actions, or events in the work environment. The speech and sentiment analysis component receives audio clips recorded with a smartphone and extracts paralinguistics features. The multi-source localization component collects information from location tracking sensors and provides accurate location information for users and objects in real time. The streaming layer ingests the data through a secure gateway and prepares them for distribution to the system. The sustAGE bridge receives data gathered from all sensors of the IoT ecosystem and forwards them for further processing via the Universal Messaging Bus. The Universal Messaging Bus supports streaming of the real-time data across the IoT infrastructure and all platform components. The personalization layer encapsulates the business logic of sustAGE. The information generated by its components enables regular updates to user profiles. Multimodal state and trait estimation infers the emotional state of users and automatically recognizes the activities they perform. Knowledge abstraction is responsible for transforming continuous flows of sensory information into compactly described knowledge items. The streaming analytics performs analytics on the incoming data to identify patterns that have occurred in the past. The knowledge base stores generated knowledge using a common format. Recommendation layer determines the recommendations that offer the best outcome to the users, taking also into consideration spatio-temporal constraints. The temporal causality and reasoning component uses past knowledge and temporal criteria to extract long-term association rules to be introduced in the predictive analytics module and predict user behaviors. The recommendation engine provides personalized recommendations for activities and tasks to each user based on his or her profile and the current or predicted user state. At the last level, the interaction layer includes the interfacing components of the sustAGE platform, which deliver the output of all previous layers to users. The dialogue manager selects the language, the priority, and the communication means for each recommendation issued to an end user. The sustAGE dashboard is a user interface that provides different views and visualizations on workforce status analytics. The game-based training activities component comprises a set of mini-games designed and developed to train cognitive skills that usually decrease with age. Finally, the end users interact with the system with the sustAGE mobile app installed on their smartphone. Results from user interaction are fed back to the system and serve as an additional input.